Okay, let me share my screen first. Hope this is visible. Is the screen visible?
Yes, sir.
Yeah. This is a slide which where we stopped the class yesterday. Yeah. Now the chat box is enabled. You can try messaging someone. Is that okay? Yeah, okay, fine. That's good. Okay. So what we were talking about Tieset and Cutset in the last class, right? So now we have studied about three different terms, matrices in the network topology. What are they? What are the topology? What are the things we were studying in this unit? What are the matrices we are discussing about? Yeah, this was the second one, right? Tieset matrix is the second one. Cutset matrix is the third one. What was the first one?
Incidence matrix.
Yeah, incidence matrix. And we have seen how to get a incidence matrix or a complete incidence or basic incidence matrix. And from that, how can you get the incidence matrix? By deleting a row, right? Fine. So now we are talking about Tieset and Cutset at the end of the class for the last class. So what do you mean by Tieset? How do you draw a Tieset matrix? How do you get a Cutset matrix? So incidence matrix just shows a number of nodes and the branches and the currents in that branches designated with some values of 1 or -1, right? Similarly, when it comes for a Tieset, we take the direction of the taking the direction of the links. First, we draw a tree we select a tree for the given graph, and we yeah. First, we draw a tree, and later on, we complete the graph using links, and we know the condition for drawing a tree. There should be no closed path for when you draw a tree, right? After the rest of the circuit is completed with the links. So once you draw the links, you can write the equation for loop currents. So we wrote it as I1, I2, I3. So what is the direction? What is the conditions here? The direction of the link currents has to be considered as the direction of the loop currents. So based on that, we can give the loop currents or the number of branches here, right? So I can give branch 4, branch 5, branch 6 here as indicated here. Sorry, link. Okay. So this link 4, 5, 6 values can be given, or the loop currents can be given here 1, 2, 3. And we can give the directions here. What's the difference between what's the commonality between incidence and Tieset? What's the commonality between incidence and Tieset? We will take these are not for these cross marks are not for Tieset, they are for Cutset actually, right? We are taking the loop currents now. What are the currents that are participating in this loop, or branches or tweaks or links are participating in this loop is 1, 2, and 4. So we take them 1, 2, and 4. We give some value 1, 1, 1. and rest of the values 3, 4, 3, 5, and 6 are not included in the loop, so we give them 0. Now once I give them 0, then what's the directions? How, where do you give, where do I give plus, where do I give minus? If the branch currents are same as the loop currents, then I give plus. If the branch currents are opposite to that of loop currents, then I give it as minus. That's it, right? So we do in the similar fashion, we do the give the values for other in the other branch for currents in the other branches as well, +1 or -1, right? Those who are participating will have some value. If not, they will get 0, right? Now Cutset matrix. So what's the Cutset matrix? How do you write the Cutset matrix? So what's the condition for taking considering Cutset or drawing a Cutset? Why do I consider node A, B, and C only as Cutsets? Why not D? Why can't I consider this as Cutset?
It should have only one twig.
Yeah, it should have only one twig. So irrespective of the number of links, it should have only one twig. So that's the reason why we have only at A, B, C, but not at D. Okay. So now when I have at A, I write it as Cutset 1. At B, I write it as Cutset 2. At C, I have Cutset 3. So how do you draw a Cutset matrix? We write the number of branches on the top as usual as in incidence and Tieset matrix. Whereas in a Cutset matrix, we give the numbers. Now the nodes at A, right? At node A, what are the elements that are participating in the Cutset is only 1 and 4. So I give values for 1 and 4, either +1 or -1. But other values, other elements or other branches are given with 0. See, I'm writing it as branches here because we are majorly concerned about the branches which was already there in the circuit here, right? These are all the branches I have 1 to 6. That's the reason always I write it as branches, either in the incidence matrix where you have all the branches. But here, what is happening in the Tieset and Cutset, we don't have consider them as branches. We are considering them as twigs and links, right? Even then I write it as branches. The same thing is done here. We even consider branches again here for writing them, for forming the matrix, right? But only these things change. Now Cutset 1 is linked with node with the branches 1 and 4. So I gave them 1, 1 first. Later on, the other elements 2, 3, 4, 5, 6, which are not participating with Cutset 1 are given 0. And what's the directions we are taking now? One which the direction of, if the branch direction of branch current is towards the Cutset, we give it as positive. If the current direction is opposite to that of Cutset, away from the Cutset, then we give it as minus. That's what is given here. +1 for branch 1 and -1 for branch 4. Clear? Similarly, take the Cutset 2. What is the branches involved? 4, 2, 4, and 5. So 2, 4, and 5 are given values of 1, and 1, 3, and 6 are given values of 0 because they are not connected to node B. And now the direction, based on the directions, we know that 2 and 4 are towards B. So we gave them positive, and 5 is away from Cutset. So I gave it as -1. Similarly, the Cutset 3 is as also given. This is what we were discussing in the last class, right? Isn't it? So we will discuss what's going on with the these elements, right? So this is a summary of how you formulate the incidence matrix, Tieset matrix, and a Cutset matrix, right? So what's the fundament? What's the representations we are using here? See, for incidence matrix we are giving A. Remember it. For Tieset we are giving B, and Cutset we are giving Q, right? And what's the rank of the matrix? And what's the number of rows and number of columns are defined by? Definitely, the number of rows are defined by the nodes in an incidence matrix. And however, in all the three, you have a commonality. What is that? The columns are described or given by the number of branches. In a Cutset, similarly, in a Tieset matrix, the number of loops will be given in the will define the value of rows. And in a Cutset, number of Cutset will define the number of rows. We also have some formulas for that. We already discussed, right? How to find the number of links, how to find the number of branches, how to find the number of nodes, right? So this is what in a theoretical format, right? We were discussing about this from the day, last two classes, right? So let us go for next thing where summary of KVL and KCL in matrix form. See, all we are doing is finding these values, right? A, this, B, and Q. These are the incidence matrix, Tieset matrix, and Cutset matrix. So after finding them, after giving them, actually for your syllabus up to that, we don't have the evaluation process, but let us have some conclusion for what we study, right? So what you have in the syllabus is to just a Cutset, how to write a Cutset matrix, how to write a Tieset matrix, how to write a incidence matrix for a given graph. But let us see where will be we employing these terms as well, right? So let us see where these values which you are getting, or the equations which you are writing from here, where we employ them. Where do you employ incidence matrix? We can employ them for finding out the branch currents and branch voltages. Just this format using incidence matrix. You can use this formula where IB is the branch currents, right? What is IB meant for? Branch currents. So now when you we can also find the branch currents by using the Tieset matrix, by using this condition. Transpose of matrix B multiply with line currents or loop currents will give the value of branch current, just like in the mesh analysis method. And similarly we also get the relation between values for branch voltages as well. Similarly, Cutset matrix can be used for finding the same branch currents and branch voltages as well, right? So in KCL form or in the terms of KVL, we can use these incidence, Tieset, and Cutset matrix, right? Just make a note of these equations, right? Or these conditions. We can get multiply A with IAB, with equating it to 0, you'll get the value of branch currents, right?
Excuse me, sir.
Yeah,
Sir, doubt, sir.
yeah.
ఎందుకు సార్ ఈ దిమాగ్ ఖరాబ్
ఆల్రెడీ నీకు ఖరాబ్ అయినట్టుందప్ప. So we can use this we can use this for finding the values of branch currents and branch voltages. And however, we can also use them for finding the loop currents as well, just like in the mesh analysis. And what's the fundamental reason why we study the network topology is that, right, we can find the branch current. We can apply the same principles of nodal mesh analysis for even for complex circuits as well, right? If the circuit complexity is high, right? If the circuit complexity is high, application of such fundamental principles, KVL, KCL, right, and mesh analysis or nodal analysis will become complicated. So that's the reason why we come for these elements, right? So let us go for one of the example here. One of the example here for calculating all these values, right? So take this example where fine. Example 1, write the incidence matrix of the graph, express branch voltages in terms of loop voltage, write the Tieset matrix, express branch currents in terms of loop currents. Take down the circuit. Let me give these directions clearly. This is from left to right. This is also from left to right. Right. So these are the directions of the currents. Right. So write the incidence matrix for this graph. Can you write the incidence matrix for this graph? Can you give a try? by using this formula, we can employ these formulas as well, right? So just give a try. Can you people try for writing the incidence matrix? Are you people trying? Okay. Go ahead. Give me the incidence matrix. How many branches we have? So how many columns you are going to get? Yeah, you are going to get 8 columns, right? So for incidence matrix, yeah, you will get it as a 8 by 8 matrix. Why? How many nodes you have for it? What is the who defines the number of columns in incidence matrix? Is the number of nodes, right? So how many column rows you are going to get?
4.
Yeah. Fine. It will be 4 nodes only, right? So what comes in the first column? So these are all branches, right? 1, 2, 3, 4, 5, 6, 7, 8. So what will be the next one is a node, right? Is this how you formulate it? Node 1, node 2, node 3, node 4, and you also have node 5 here, right? So you have a fifth node as well here. This is also considered as given as node here, right? I think 1, 2, 3, 4. This is, I think you can take a node here. Yeah, in the diagram, this is missed, right? You can take it as node 4. So to differentiate between nodes and branches, they have given them in the brackets, right? Now, how many? You have 5 nodes. You have 8 branches, right? Now just write the basic fundamental incidence matrix. What's the equation you can write here? So what about this first branch? Branch 1. So what's the first? What will be the values in the first column?
1, 5, 8 will be positive. Remaining all are 0.
You are going to say like this in the row fashion or in the column?
Rows
Horizontal or
are
vertical?
horizontal.
Horizontal, right? Okay. Okay. Tell me the values. 1.
5 and 8 are a positive 1. Remaining are 0.
Okay. You want to say this as 1, 5, and 8 are positive, right?
Yes, sir.
And rest of them are zeros. Is that you said? Is that what you said?
Yes, sir.
Fine, fine. So what about the second one? Second row.
2 and 6 are 1, sir.
2 and 6 are 1, right? 2,
And 5 is -1.
yeah. 5, 2 is 1, 5 is -1, and 6 are 8.
6,
6,
sir.
sir.
6 is 1, huh?
Yes, sir.
Okay. Rest of them are zeros. Okay. What about node 3?
3 and 7 are positive. 6 are negative. Remaining 0.
3 and 7 are positive. 6 and 8 are negative. And rest of them are
Remaining.
zeros. That's it?
Yes, sir.
Okay. Node 4.
4 is 1 and 7 is -1.
7 is -1. And rest of them are
0.
0. Okay. Fifth node.
1, 2, 3, 4 are negative. Remaining are 0.
-1, -1, -1, -1, and all are zeros, right? Is it okay for everyone, or is there any problem in writing this? Yeah, Bharatraj, did you join the meet? What's his number? Bharatraj. Okay, is this everyone got this matrix? Okay, I can see only 2 S's. 20, yeah,
Yes, sir.
okay. Okay. What about others? Only 4, 5 S's, 5, 6. What about others? At least give it a try. It's very simple, right? To write an incidence matrix. Okay. Okay. So Bharatraj, did you join? Yeah. So okay. Similarly, write a Tieset matrix. Let us do 2 and 4 later on, but just we'll write the branch voltages in terms of loop current, loop voltages later on. But write the Tieset matrix. So first, what is the first thing we have to do for writing a Tieset matrix? What is the first requirements for how do you write it Tieset matrix?
First, we have to know number of rings and links to draw the tree diagram.
Yeah, first we need to choose a tree, right?
Yes,
So what's the
sir.
condition for drawing a tree?
Same number of nodes, but then there should be no closed paths.
Yeah, there should be no closed paths, right? Bharatraj, did you join the meet? Yeah, make tree with no closed paths or take a tree, right? Yeah. Bharatraj. Yeah, rule number 22. Am I audible for you? Rule number 22, Bharatraj. Please respond. Rule number 22. Am I not audible for you? Rule number 22. Rule number 522. Hemant, call him and make him respond once. Just inform that I'm asking for him.
Okay, sir.
Rule number 22.
Yes, sir. Yes, sir. Hello.
Rule number 22. Are you there?
Yes, sir. Yes, sir. Yes, sir. Hello.
Fine. So what is the first thing we have to do take when we draw a Tieset matrix is yeah. We draw a tree, right? So what's the tree we have to consider? Or is there any condition for taking how many trees we can draw for this diagram, for this graph? What are the ways we can use numerous ways, right? For drawing a graph or drawing a tree for this. So let us use for simplify. I mentioned some values here. Use tree 5237 to just make it simple, right? So what are the elements that are used here is just like this. I'm drawing a tree here. See, sorry, just start here between 1 and 2. What's the condition? We need to meet all the nodes, right? We have to connect all the nodes. So this is 1, 2, 3, 5. This is 4, right? Now let me take twig. This has one twig, right? And this has another twig. Let me take this as one twig, second twig, third twig, and this has fourth twig. That is This is twig number 5, branch number 5, branch number 2, branch number 3, and branch number 7. There is no fixed condition that you will be doing with this only these branches. Because I have solved for these, and I just gave an indication hint to do so. So you can even take any other tree, whatever the tree you wish to draw, you can draw, right? So don't consider this. You can take your own diagrams, your own tree, right? And draw a. We can go for writing a Tieset matrix. Is that clear? Just for commonality, I just gave this reference, right? Because if I write it in on the board, then it will be final, right? So now tell me what will be the Tieset matrix will be. How do you, what's the next step? First we took a tree. So what's the next step procedure or next step to do?
Draw links and assign mesh currents.
We have to draw links, sir.
Yeah, we have to complete the graph by using the links, right? So in place of missing branches, we draw some what do we say them? We draw the links. Okay. So let me take this. This is missing here. A branch is missing here. So I fill it with a what do you say? Fill it with a link, which is number 6 here, right? Similarly, what is missing here? We are missing a branch here. So I may fill it with a link. So this is 4. And what about this? Between 1 and 5, branch 1 is missing. So we will give a link here. Similarly, there is a missing branch here, which is number 8. I provide with the link. Okay. So similarly, I have to give some directions of currents as well for all the links, right? I am giving the direction of currents here. Right? Is that okay? The directions also or has to be mentioned. Why? Right. Is this okay?
Yes.
Yeah. Fine. Now, yeah. Yeah. So now, what's your next class?
Python lab.
Python lab. Inform me when Madam Sir joins. Okay, let us request for 5 more minutes. Okay.
Okay,
Okay.
sir.
Fine. So now, after drawing this, what has to be done first? Next, draw a matrix, right? So
Mesh
similar.
currents, sir.
Yeah.
Mesh currents.
Okay. So we do the same thing here. We'll give the branch numbers here 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Now, what has to be drawn here in the type for a Tieset matrix? How many loop? We have to write either the link, this link number, or we can write the loop current numbers, right? So, what is the loop currents has to write? Say, I can take this one loop where I have some. I can assume some direction of loop current here. I write it as I1. Why I'm taking in this direction as anti-clockwise? Why I'm taking anti-clockwise direction of this current? Because the direction of this link is in this direction, right? That's the primary condition, right? So let us take the loop current here as 2. What is the direction I has to give? Same as direction of current in link 6. This is considered as I2, right? Am I clear? So let me take this. Yeah, let me take this as I3, where the direction of this current will be same as this link current. I write it as I3. And here I take it as I4, where I can take the direction in the direction of link current H. Am I clear? I think we don't have 2 links to follow, right? We here in this loop, see, we have two links in common here in between these 2. So we consider I4, but we consider this, instead of taking this link, we take this whole branches, right? Because there is a condition for this writing the Tieset matrix. What is the condition we have? We should have only one link, because if you have two links, what's the direction of current we are going to take? So what's the link we has to take? What's the direction we have? What's the loop we has to take? We're writing them as loop currents. You know the difference, right? We are not writing the mesh currents. Am I clear? What's the difference between a loop current and a mesh current? Yeah. What's the difference between the loop currents and the mesh current? For a mesh, there should be no loop within, but for a loop currents, see here we are writing the equation in terms of loop currents, right? Isn't it? In terms of loop currents. So we can write a loop current of I4 in for this loop. Which loop? For having only one link, what has to do? We can't write the loop current for this only these elements, right? 5, 4. అర్థమవుతుందా? ఇక్కడ లింక్ వస్తుంది కాబట్టి what has to do? We can write the link loop current for these elements. For which loop? Start from this node 2, go to node 1, go to node 3, go to node 5, and come back to node 2. Is that fine? So give a try and get the Tieset matrix. We'll be discussing about the how do you bring out these branch currents and branch voltages, right? In the next class. Yeah, ignore sixth link because we are writing the loop currents. We can write with other ignoring that, right? That's what we are talking in the loop currents, right? Loop current, loop is nothing but which can have another loop within or mesh within, right? So we don't have, suppose if you consider sixth element, sixth link, what will be the direction of the current? You have two links in two opposite directions. So we want only one link to be present, right? Suppose if I eliminate, ignore this, then in the path which I said from node 1 to node 2 to node 1 to node 3 to node 5 and back to node 2, that will also be a loop current, right? So okay, we can use that. Is that clear? Yeah. So we will continue the same in the next class. Okay. CR, post the attendance, please. Yeah.